Hello student, today we are going to study Chapter 2 Matrices in paper 1. In Standard 11, we have studied the types of matrices, algebra of matrices. Let us briefly recall about the matrices and algebra of matrices, which you have already studied in Standard 11. First, see the definition. An arrangement of Mn numbers in m rows and n columns enclosed in square bracket is called as the matrix. For example, -1 elements 2, 0, 3. This element enclosed in square bracket. Therefore, this matrix is called as the matrix of order number of row equal to horizontal line. First horizontal line is denoted by first row. Second horizontal line is denoted by R2. First column is denoted by C1. Second horizontal vertical line is denoted by C2. Number of row equal to 2 and number of column equal to 3. Therefore, this matrix always denoted by capital letter. This matrix of order 2 by 2. Now, see the types of matrices. First, row matrix. A matrix which contain only one row is called as the row matrix. In generally, it is written as A equal to in matrix Aij equal to 1 by n. Suppose matrix B is denoted by one row -1, 3, 2. In this matrix, number of horizontal line is 1, that is number of row equal to 1, and vertical line is nothing but 3, that is number of column is nothing but 3. Therefore, this matrix is called as the row matrix. Second example, A equal to -1, 0. In this matrix, number of row equal to 1 and number of column equal to 2. Therefore, this matrix of order 1 by 2. Therefore, A matrix also called as the row matrix. Second matrix is nothing but column matrix. Column matrix definition: a matrix which contain only one column in is called as the column matrix. In generally, it is written as capital A equal to in matrix small aij m by n. For example, X matrix contain only one column and number of rows. Number of row is nothing but 2, -1, 3. Number of horizontal line is 3, R1, R2, R3. And column is nothing but only 1. It is denoted by C1. Therefore, X matrix of order 3 by 1. Therefore, X matrix is called as the column matrix. Third, rectangular matrix. Rectangular matrix, a matrix capital A equal to in matrix Aij of order m by n is called as a rectangular matrix if number of row is not equal to number of column. For example, A matrix equal to 1, 2. In this matrix, order is nothing but one horizontal line, that is number of row equal to 1, number of column equal to 2. Therefore, M not equal to N. Therefore, this matrix is called as the rectangular matrix. Second example, matrix X contain elements 2, 0, 1, 3, 4, 3. In this matrix, number of row is nothing but 3 and number of column is nothing but 2. M not equal to N. Therefore, X matrix also called as the rectangular matrix. Next, square matrix. A matrix capital A equal to small aij of order m by n is called as the square matrix if m equal to n. For example, A equal to 1, -1, 0, 2, -1. In this matrix, number of row equal to 2, R1, R2, and number of column also 2, that is m equal to n. Therefore, A matrix is called as the square matrix. Second example, B matrix contain elements 0, 1, 3, 2, 4, -5, 3, 6, 7. In this matrix, number of row is nothing but 3, R1, R2, R3, and number of columns C1, C2, C3, that is number of row equal to 3, number of column equal to 3, both are equal. Therefore, B matrix also called as the square matrix. Next, diagonal elements. A square matrix if I equal to j. In this square matrix, A11 position elements -1, A22 position elements also -1. Therefore, these elements is called as the diagonal element. In second matrix, diagonal elements is nothing but 0, 4, 7 because I equal to j. Non-diagonal elements that is a square matrix if I not equal to j. For example, I not equal to j. The non-diagonal elements is nothing but 0, 2, and in this matrix non-diagonal elements 1, 3, -5, 2, 3, 6 is called as the non-diagonal element. Diagonal matrix. Diagonal matrix is nothing but a square matrix capital A equal to small aij of order m by n if aij equal to 0 when I not equal to j. Matrix diagonal matrix, suppose A equal to 1, 4, 3 and non-diagonal elements 0. Therefore, this matrix is called as the diagonal matrix. Second example, C matrix contain element -1, 7, non-diagonal element 0. Therefore, this matrix is called as the diagonal matrix. Scalar matrix. A equal to small aij if non-diagonal elements are 0. Aij equal to 0 when I not equal to 0 and Aij equal to k when I equal to j where k is a real number. For example, C matrix contains 1, 1 and non-diagonal element 0. Second example, D matrix, no, diagonal element 4, 4, non-diagonal element 0. Therefore, this matrix is called as the scalar matrix. Now, identity matrix. It is also called as the unit matrix and it is denoted by I. In generally, a matrix capital A equal to small aij matrix, that is aij equal to 0 when I not equal to j and equal to 1 when I equal to j. For example, a matrix D contains elements, non-diagonal element 0 and diagonal elements 1. This matrix is called as the identity matrix and identity matrix always denoted by I. This matrix is nothing but square matrix of order 2, that is 2 by 2. Therefore, matrix is denoted by I2 also. Second example, I3 matrix, that is diagonal elements 1, 1, 1 and non-diagonal element 0. This matrix is called as the identity matrix, unit matrix and it is denoted by I3. And 0 matrix, it is also called as the null matrix and it is denoted by 0, a square matrix. All element 0. Second example, 0, 0, 0, 0, second row elements, third row elements also 0. Therefore, this matrix is called as the 0 matrix. 9. Triangular matrix. There are two types of triangular matrix. First, upper triangular matrix, lower triangular matrix. A matrix A equal to small aij, that is aij equal to 0 when I greater than j. That is matrix is denoted by A, 1, 3, 2, and diagonal element is nothing but 1, 2, and non-diagonal elements 3, 0. Below the 0 below the diagonals elements, therefore this matrix is called as the triangular, upper triangular matrix. Second example, X matrix contain elements minus 7, 6, 5, 2, 6, 9, and below the elements 0. Therefore, this matrix also called as the upper triangular matrix of order 3 by 3. Lower triangular matrix. A matrix A equal to in matrix Aij, that is Aij equal to 0 when I less than j. For example, B matrix contain elements, diagonal elements 7, 9 and minus 6. Upper elements 0. Therefore, this matrix is called as the lower triangular matrix. Similarly, of order 3. Next, determinant of matrix. Determinant of matrix. Suppose A is a matrix. First row elements minus 1, 5, second row elements minus 3, 2. Is a square matrix also. Therefore, determinant of A written as two vertical lines. Write the elements in two vertical lines. And we can simplify these elements. Minus 1 into 2 minus 3 into 5, and simplify this equation, we get 13. Similarly, taking the second example of order 3, A equal to in matrix first row elements 1 minus 1 2, second row elements 3 0 minus 2, third row elements 1 0 3. Now taking the determinant, these elements in two verticals line, that is determinant of A is nothing but first row elements minus 1 sorry 1 minus 1 2, second row elements 3 0 minus 2, third row elements 1 0 3, and simplify this equation. 1 into 0 into 3 is nothing but 0, minus 2 into 0 is nothing but 0. This sign always negative, negative into minus 1, that is plus 1. 3 into 3 is nothing but 9, minus 2 into 1, that is plus 2, and plus 2. 3 into 0 is nothing but 0, minus 1 into 0 is nothing but 0. Now we can simplify this equation, we get determinant of A equal to 11. Next, non-singular matrix. A matrix A equal to in matrix Aij if determinant of A is not equal to 0. For example, A matrix contain elements 4, 5, minus 2, 1. Now find the value of determinant of A. 4, 5, minus 2, 1 written in two verticals line, and simplify this equation. Determinant's value is 14, which is not equal to 0. Therefore, A is called as the non-singular matrix. Now, second, singular matrix. If a matrix A equal to small aij, if determinant of A equal to 0. For example, A equal to matrix 3 0 1 0. Find the value of determinant of A. Determinant value is nothing but 0. Therefore, A is called as the singular matrix. Now, transpose of matrix, and notification of this transpose of matrix is denoted by A raised to T or A apostrophe S. That is, if A is a square matrix, interchanging row and column simultaneously is called as the transpose of matrix. It is also called as a matrix obtained from the matrix A by interchanging its row and column is called as the transpose of matrix, and it is denoted by A raised to T. For example, given matrix is nothing but A equal to elements. First row element 5, 6, 7, second row elements minus 1, 2, 3, third row elements 4, 5, 6. Therefore, A transpose is nothing but first row elements right in a first column. First row elements 5, 6, 7 right in a first column, that is 5, 6, 7. Second row elements minus 1, 2, 3 right in a second column, minus 1, 2, 3, and third row elements right in a third column 4, 5, 6. Therefore, this matrix is called as the transpose of A, and it is denoted by A transpose. Now, symmetric matrix. If a matrix A equal to small a I j, if A equal to A transpose, that is elements A I j equal to A j I. For taking the examples on symmetric matrix, A contains elements minus 2, 1, 1, 5. Therefore, A transpose. First row element in first column. First row elements minus 2, 1, write in a first column. Second row elements, write in a second column. Therefore, this value is nothing but A. That is A equal to A transpose. Therefore, A is called as the symmetric matrix. Second, skew symmetric matrix. A matrix A equal to Aij if A equal to 8 minus A transpose, that is elements Aij equal to minus Aji for all and j. Taking the examples on skew symmetric matrix. A contains elements 0, 4, minus 1, minus 4, 3, 2. Third row elements 1, minus 2, minus 5. First row elements in first column 4, 0, minus 1. Second row elements right in second column, and third row elements is right in third column 1, minus 2, minus 5. We observe these elements, we get A equal to minus A transpose. Therefore, A is called as the skew symmetric matrix.